The topic for today is the electrolysis of some common salts. In the electrolysis of some common salts, the positive ions migrate to the cathode, while the negative ions migrate to the anode. You are welcome. Electrolysis of aqueous copper 2 tetraoxosulfate 6 solution. Copper 2 tetraoxosulfate 6 solution will ionize to give copper 2 ion plus tetraoxosulfate 6 ion. Water will also ionize to give hydrogen ion plus hydroxide ion. The hydrogen ion and the copper 2 ion will migrate to the cathode, while the tetraoxosulfate 6 ion and the hydroxide ion migrate to the anode. At the cathode, which is made of copper or carbon or platinum rod, copper 2 ion will be discharged since it occurs below hydrogen in the electrochemical series. Copper 2 ion will acquire 2 electrons and be deposited as a neutral copper. The cathode grows thicker because of the discharge of copper. At the anode, which is made of carbon or platinum rod, hydroxide ion is discharged since it is higher than tetraoxosulfate 6 ion in the series. Hydroxide ion in aqueous state goes to hydroxide plus an electron. So OH plus OH will give water plus O. Then O will also combine with O, which is oxygen, to give us oxygen molecule. That is a gas. At the cathode, 2 molecules of copper 2 ion will acquire 4 electrons to give 2 molecules of neutral copper. At the anode, 4 molecules of hydroxide ion will lose 4 electrons to give 2 molecules of water plus 1 molecule of oxygen gas. The overall reaction is 2 molecules of copper ion plus 4 molecules of hydroxide ion to give 2 molecules of neutral copper plus 1 molecule of oxygen gas and 2 molecules of water. As copper is discharged, the solution becomes acidic due to the hydrogen ion and the tetraoxosulfate 6 ion in the solution. There will be gradual fading away of blue copper 2 tetraoxosulfate 6 acid. If current is continuously passed, electrolysis of tetraoxosulfate 6 acid will begin to take place. Electrolysis of concentrated copper 2 chloride. The cathode is copper and the anode is carbon. Copper ion and hydrogen ion will migrate to the cathode, where copper is preferentially discharged. Hydroxide ion and chloride ion will migrate to the anode, where chlorine will be discharged because of higher concentration. The electrolyte will become more dilute as copper 2 ion and chloride ion is removed from the electrolyte. Electrolysis of dilute copper 2 chloride. Copper is discharged at the cathode, while oxygen is discharged at the anode. The concentration of hydrogen ion and chloride ion in the solution makes the electrolyte more acidic. Electrolysis of dilute sodium chloride using carbon cathode and carbon anode. Hydrogen is discharged at the cathode, while oxygen is discharged at the anode because hydrogen ion is lower than sodium ion in the series and hydroxide ion is higher than chloride ion in the series. The solution becomes more concentrated. Electrolysis of concentrated sodium chloride using carbon cathode and carbon anode. Hydrogen will be discharged at the cathode, while chlorine will be discharged at the anode due to the higher concentration of chloride ion. The solution will become alkaline because of the presence of sodium ion and hydroxide ion in solution. Exercise 1. In the electrolysis of brine, the anode is A. Platinum, B. Copper, C. Zinc, D. Carbon. The correct answer is carbon because the electrode is made of carbon. Exercise 2. In the electrolysis of a concentrated solution of sodium chloride using inert electrodes, which of the following ions are discharged at the cathode and anode respectively? A. Sodium ion and chloride ion, B. Sodium ion and hydroxide ion, C. Hydrogen ion and hydroxide ion, and D. Hydrogen ion and chloride ion. The correct answer is option D, because hydrogen ion is discharged at the cathode and chloride ion is discharged at the anode due to high concentration of chloride ion. Exercise 3. The products of the electrolysis of dilute sodium hydroxide using platinum electrodes are A. Hydrogen and oxygen gases, B. Water and hydrogen gas, C. Water and sodium metal, and D. Sodium metal and oxygen gas. The correct answer is option A. Hydrogen and oxygen gases.